Welcome to the video on calculations with scientific notation. So first we'll talk about what scientific notation is. Scientific notation is when you take a really large or really small number and you put it in the form of a times 10 to the k, where a is some number where you have one number before the decimal place, for example, like 3.268. So you'd have one number before the decimal place and any number of numbers after the decimal. And then it's multiplied by 10 to some integer. So any whole number, positive or negative. So for example, if you had the number 4,320,000, we could turn this to scientific notation by moving the decimal 1, 2, 3, 4, 5, 6 places to the left. So it would be 4.32 times 10 to the 6th. So as you move the decimal to the left, so when you go to the left, your exponent will get larger. And then when we move to the right, our exponent will get smaller. So you could also have a small decimal such as 0.00039. And we could write that in scientific notation by moving the decimal 1, 2, 3, 4 spots to the right. So it would be 3.9 times 10 to the negative 4 because it's a smaller number. So some real life uses of scientific notation are things such as Avogadro's number. So Avogadro's number is 6.022 times 10 to the 23rd, which is used frequently in chemistry for calculations. You could also write out microscopic measurements or really small measurements using scientific notation. For example, this number right here, you wouldn't want to have to write a decimal followed by 37 zeros before a 158, which is why you would just write it in scientific notation. An important thing to note is on your calculator, it'll write scientific notation like this, 2.5E12, as shown here. You never want to write something like that on a test, this E. You'd always want to write it out 2.5 times 10 to the 12th. On a test, they won't take something like this. That's the same thing with really small numbers. This 2.5 e negative 9 is the same as 2.5 times 10 to the negative 9th. And you would always want to write it in this form, not in this form. So when we add and subtract numbers in scientific notation, there are some steps we want to follow. So first we want to move the decimal in our a value. So our number in front, we want to move the decimal to have the same exponent, k. And a tip here is to move the numbers so that k is the larger value. Here we can take our 2.4, and if we move it over 2 more times, we can add 2 more to our exponent. So we get 0.024 times 10 to the 6th plus 4.6 times 10 to the 6th. So to add those, we'll line up our decimals. We have 0.024 plus 4.6. So that'll give us our 4.624, and it's going to be times 10 to the 6th. Our last step is to move the decimal in A in order to have one number before the decimal. Because we followed the tip, most of the time, you'll only have one number before the decimal and not have to make any more adjustments. So our answer here would be 4.624 times 10 to the 6th. So for the second problem, we want to get our exponents to match the bigger k value. So this is the one we're going to have to change. So our 5.3, we're going to move it over twice, 1, 2. So that we can add 2 to the exponent times 10 to the negative 2. And then we'll have 1.4 times 10 to the negative 2 minus this. So we have our 1.4 minus 0.053. Line up our decimal. And then we can borrow from here and do our subtraction. So we end up with a final answer of 1.347 times 10 to the negative 2. Next, we can work on multiplication with scientific notation. The first step is to multiply the a values to get a new a value. So we would multiply 2.4 times 4.8. So you get 32, carrier 3, 16 plus 3 is 19, have a 0, 16, carry a 1. 4 times 2 is 8, plus 1 gives you 9. And when we add these, we end up with 1152. We'll move our decimal over twice up there, so we're going to have a decimal right here. So we have 11.52. Then the second step is to add the k values to get the new k value. So we'll do 4 plus 6. So our new k value is going to be 10. So we get 11.52 times 10 to the 10th. And then we have two numbers before the decimal, so we're going to need to move the decimal to the left one. 1.152 times 10. Since we moved it to the left one, we're going to add one more to the exponent here. And that would be our final answer here. We'll follow those same steps for this second problem here. So 1.4 times 5.2, get 8, 2, 0, 2, 7. So this is 728, and we'll move our decimal in twice, so 7.28. For our k value, we have negative 2 plus negative 4, so we'll have a negative 6. So we have 7.28 times 10 to the negative 6. And we only have one number before the decimal place, so this is our final answer. For dividing with scientific notation, the first thing we're going to need to do is to divide the a values to get a new a value. So we'll take our 4.8 and divide that by 2.4, which just gives us 2. And then we'll find our new k value by taking these k values and subtracting them. So we'll do 4 minus 6, which gives us a negative 2. So then we get 2 times 10 to the negative 2. And since there's just one number, then we don't need to move any decimals. So this is our final answer for this problem. For our second problem, we have 2.415 divided by 3.22, which gives us 0.75 for our new a value. Our k value will be negative 2 minus a negative 4, which is just negative 2 plus 4, which gives us a positive 2. So we have 0.75 times 10 squared. So our final step for this problem is going to be moving the decimal. We're going to need to move it 1 to the right because we need the 7 before the decimal place. Since we're moving it to the right, we're going to need to subtract 1 from our exponent. So we'll have 7.5 times 10 to the first, which is also just equal to 7.5 times 10. Finally, we have our scientific notation raised to a power. And to do that, we're going to start by raising a to the p power to get the new a value. So we have 1.2 squared. And then we're also going to have times our 10 to the 6th squared. So we'll square each individual thing. So 1.2 squared is 1.44 times 10 to the new k value. So our new k value, we're going to multiply k by p. So 6 times 2 is 12. So this would be your answer because we are in the correct form for scientific notation. For the second problem, we have 5.2 cubed times 10 to the negative 4th cubed. So our 5.2 cubed is going to be 140.608 times 10 to the negative 4th cubed. So we do our negative 4 times 3 will give us negative 12. So here we have 3 numbers before the decimal, so we're going to need to move it 2 to the left, and we get 1.40608 times 10 to the negative 10, because we're going to add 2 more to that exponent because we moved it 2 to the left. In summary, when we're adding and subtracting numbers in scientific notation, we need to make sure we get the same k value, and then we can add or subtract our a values to get our final answer. In multiplying, we multiply our a values and then add our k values. For dividing, we divide our a values, then subtract our k values. And then when we're raising scientific notation to a power, we're going to raise a to that power and then multiply k by that power. And obviously at the end, we'll go through and make sure that it's in the correct form where there's only one number before the decimal. That's all you have to do for calculations with scientific notation. Thanks for watching.